Okay, so developing an equation. Let's write at the top of this page what we kind of know. So the first thing we learned was that that's one way to write a quadratic. And then the second thing we learned is that k number could actually just been on the other side, right? So it's the same thing, but just was moved over here. Okay, that is the exact same thing. It's just the movement of a number. And, oops, we've learned this. So we have three forms that we've looked at. So we either have to make it look like something like that, one of those. Okay, question 1. You're given a vertex and you're given some other point. We're going to figure out the equation. Okay, there are two methods to this. One's algebraic and one's the graphing method. I'm just going to actually do the graphing method because every time I've tried both, everybody picks the second one anyway. Okay, so 2, -4. I'm just going to kind of put it as a general, I don't need to be too precise here. That's my vertex. I put a V there. Vertex 2, -4. And then if I went to 4, 4, there's a point. Okay, so just a general sense of where they are. And then if I drew a parabola through them, what do you know about parabolas when they go through a vertex? Right, it'd have to go from here as a start bottom and then up somehow, right? Okay, so here is my question. Tell me my movement. How did I get to that point? I've moved, so in other words, over what, up what? So this vertex was at 2, and now this one's at 4. So that has made me move over 2. Forgetting a comma in there. This was at a height of -4, and now this coordinate was at a height of +4. So what's that traveling? Up 8. Okay, let's look at normal. Did we do what we normally should have done? No. So this is what I'm looking at. If I move over 2, I should only head up 4, but we moved up 8. So was there a multiplier? Yeah. What? What is my multiplier going to be? Okay, so I'm multiplying by 2, right? Because instead of 4, I did 8. So we're going to go the slope multiplier was 2, and the vertex is 2, -4. So those are my big items. You always need to have a vertex, you always need to have a slope. Okay, so which form am I going to pick? I'm going to pick one of these ones. Not that. Doesn't matter. These are the same. So you have to plug your vertex in and your slope in. So do you remember your vertex is the h number and the k number, right? And when you write equations, Your y and your x parts always have to stay as y's and x's because that's the function. So you could have done y equals 2x minus 2 squared minus 4. So remember what I'm doing also? What was this? Opposite number, same number. Opposite, opposite number. Okay, you don't have to write both. I'm just saying I would accept that answer, I'd accept that answer. Either one. Okay, depending on which one you picked. Okay, so your slope, your vertex. Make sure when you plug those vertex parts in, you're understanding if they should be opposite things or the same thing. Okay, we know that a quadratic has x-intercepts at 5 and at -4. So I don't know, could look like whatever. This is what's visually going on. They have y or x-intercepts going on. So you learned this yesterday. So how did we get x-intercepts yesterday? Does anybody remember what we were doing? We were always getting those x-intercepts on the very last assignment you did. It's the F word. Factoring. So we had some equation. What did we do? We made, right? This is what we were doing. We had some equation. We made y 0, right? Because that's what's happening on those points. We factored we did that. So what am I going to do? I got to work backwards of what we just did yesterday. Okay? Do you see it? We'll have an equation. We'll factor it to get our x-intercepts. Okay, so if this is the x-intercept, what's going on in that bracket? X plus 4 was in that bracket, and x minus 5 was in that bracket. Okay, and then this was factoring, so how do I, that was a factoring, how do you work backwards of factoring? What's an opposite thing to factoring? Foiling it. Foiling and factoring are opposite. Okay, so FOIL it, what do you get? Okay, does that make sense? So yesterday we took an equation, we made y 0, we factored it, and got our x-intercepts. So I'm undoing it all. Okay, on these ones I've given you a chart. Okay, so on a quadratic, on a parabola, we always think like this. Symmetric partners, right? Symmetric partners. But the vertex is all alone. Right? That's kind of how it will always work out. Everything will have a partner to its symmetry, except a vertex. Okay, so then we're thinking of that now. So if I look on this chart, hey, guess what? This point and this point are symmetric partners. Right? This point and this point are symmetric partners. If I kept going in my chart, who can predict me the next coordinate? Four comma -13, because it would have to partner with this one. So what's the next point? Has to be a partner to this one. So it would have been 5 comma -27, right? Okay, can I conclude? That's all alone then. So this is my vertex. Okay, so that's good. Vertex. Now, I need to figure out that slope multiplier. So let's figure out a pattern. So let's travel here. 1 to 2 on an x means you have moved over by 1. And a y value of 5 to 3 means you're moving down 2. Okay, and it's the same thing onto the other side, right? Over 1, down 2. Let's try another move. So here it has made me go from 1 to 3. So that means that has moved over by 2. And if I head from 5 to -3 height, that is making me move down 8. Can anybody figure out your slope A value? Because that's not normal, remember? Normal, 1, 1, 2, 4, right? Normal is 1 and then 1, but you went down 2. 2 is normally 4, but you went down 8. What are you multiplying by every time? -2, right? Because I went down, down. Okay, this is the same as question 1 now. Can you get me something, one of these? You got to fill in your vertex and you got to fill in your A value. Okay, again, you don't need both things, you just need one or the other. So depending on where you wanted to put your 5, if you wanted to put your 5 on this side or at the end, doesn't. Okay, should I let you try this one on your own? Number 4, it's the exact same question. Can you figure out where the symmetry partners are, and then that will dial in on where your vertex would be? So they'll have a bunch of symmetry partners except for okay, so I found my vertex. I had some partners with this thing and this thing, so then that ended up in the middle alone. Okay, obviously this would have a partner its partner would have been if I had kept going that way, right? Okay, so now you need to take off from your vertex and travel. So from my vertex, how did I get over here? So I would have had to move over 1, and then I would have had to move down 1. 5 to 4 is a down. Okay, so I should figure out what my slope number is. What's this multiplier of the pattern? So if I move over 1, I should have gone up 1, and I went down 1. If I move over 2, I should have gone up 4, but I went down 4. So what am I doing every time? I'm multiplying this by -1. Okay, so once you have your important info, vertex, slope, okay, -1 in the front, x plus 2 squared, and you're either doing a +5 there or -5 on the y side. Okay, can you write this out for me on this next one? Transformation form, because I can see flipping, shifting right. I'm going to talk about transformations here. Okay, so here we go. A quadratic gets flipped downward. So if I'm flipping downward, what's changing in this? I know that's going to have to be a negative value then, right? A, that's an A. Getting flipped, that's an A. It's going to shift 2 to the right. So this is going to change. So I'm going to do a right 2. So that's going to have to change there. And it gets narrowed. So it says when I go over 2, I went up 12. So if I dial in on my chart, when I went over 2, I should have done 4, but instead of 4, we did 12. So therefore, I'm multiplying by 3. And that 3 is that narrow. Anything over 1 makes it narrow. Okay, so there's what I know. This had to negate, it had to be 3 to narrow it. So I'm going to go y equals -3 bracket x minus 2 squared. There's the flip, there's the narrow. This makes something shift right 2 because it's opposite. Okay, last question today. I need you to look at your graph and I need you to say what's the vertex and what's the slope. So the vertex is the coordinate did you do 3 comma 5? Okay, I need to grab some points. Do you see any perfect points? I would say those are perfect points. When's the next time that you hit an intersection? I think -3. Okay, so those are looking like they're perfect points. So can you figure out your over-up pattern? So this means I'm going to move over 1 and down 2. Over 2 and down 8. Do we have a multiplier now? So there's your A is -2. Because you should have gone up 1 and you went down 2. You should have gone up 4, but you went down 8. Okay, so there, plug it in. Okay, so both of those answers are correct. You don't have to write them both down. You pick which one you like. Either the 5 was there or the 5 was there. Okay, but if it's here, it's the same. If it's here, it's an opposite. Okay, I'm going to do one in your homework with you. 5. Page 5, question 1. So question 1, and I'm going to look at graph D. So when you're doing this in your homework, there's an A, B, and then on this graph has the C, D, and the E. Okay, so I zoomed in here like that. Okay, so what's the things I need to do? First of all, there. That is my vertex, which is 0, 0. And now I have to do a pattern to get my multiplier slope number. So the only point I have is this. Okay, so this is the guideline of what I should do. I should be doing this, but what did we do instead? So this move has made me go, what? Over 3, comma, what did I do? Up 1. Okay. So I'm dialing in here. I went over 3. I should have gone 9, but I just went 1 instead. So what is my multiplier? Okay, and here's my hint. Do you remember what makes it wider? What's going on with A if you're wider than normal? A is less than 1. If we're smaller than 1, you're probably going to think decimal, fraction, right? Would that make sense? Decimal, a fraction. So could you think of a fraction that would work there? 9 times what fraction could turn into a 1? Mental math. How about division? 9 divided by what? Makes 1. That's not a trick question. 9 divided by what makes 1? 9 divided by 9 makes 1. So therefore 9 times Okay, quiet people. Here's a candy. Who has a fraction? 1/9. Right? Do you see it? 9 times 1/9. Right? Because then it cancels away my 9s and I get a 1. Is this smaller than 1? Would it make something wider? Yes. Okay. How's your equation going to look? This is what you've now given me. You have vertex and an A. Y equals 1/9 x squared. Right? Because you're not going to put any number in the bracket and you're not going to put any number at the end. So you have 0 and a 0.